proposed to do a survey of the Leaving Cert higher level maths students in Ireland and asked them which topic that they did not like, which was the hardest on the course. I'd suggest the one that we were going to do here would definitely be within the top 3. And it's very, very simple why. Students don't have basic concepts which then add up to massive problems when we actually bring them all into a Leaving Cert question. So what we are going to do here is I'm going to tell you a little bit about what we're going to do, which is logs, and then we're going to talk about how it's going to be worth between 4 and 8%. But more importantly, what I'm going to say to you is the perceived difficult questions at Leaving Cert higher level are actually not from the questions themselves. They're from a little gap that every student has in their maths, even the strongest students, whether it be from being sick one day, a teacher not emphasising certain things for the future because they're just focusing on what's maybe in 2nd or 3rd year. And by actually addressing those, very often we can see students' grades increase dramatically. So logs in general, like we could talk about log equations, we could talk about how logs in disguise come in where we bring them into questions and use their rules, but what we're going to focus on here is something called a log story. And it really throws students, because one year we could be talking about the population of bacteria, then we could be talking about carbon-14 dating, such as in 2013, and the question we're going to do is talking about actual percentage risks of car accidents. And that automatically throws students because it's unfamiliar, but what I want my students to recognise is there's always going to be a formula and we're always going to apply similar rules. So what you have to have in the background is, one, a really good grasp of indices. So if you have a really good grasp of indices and those rules, we're going to use them a serious amount in solving these log questions. The logs are almost irrelevant. The second thing though, and I know this sounds a bit contradictory, is you have to understand the log rules, but almost to a lesser extent than the indices ones, because there's one that's massively important for us here. And the thing that's massively important is if we have a log such as, say, 3 log of 7 to the base 2, one of the famous rules we have is we can take this number and put it up here as a power. So that could also be written as the log of 7 cubed to the base 2. And like, that's fantastic, that gets pointed out to you and you use that the odd time in the log equations and stuff. But what is not emphasised, and this is what I'm trying to emphasise here, is that we can actually go the other way. And that's going to be massively important for us. We're going to take that power and bring it down in front of the log. Okay, and the second thing I want you to know for our introduction here, for pretty much every single one of these log stories, is we are going to figure out and use the fact that the ln of e, or the natural log of e, if you're not too versed in it, that's the same, not to a massive mathematician like a massive geek, but to a layman, that's the same as this, but the ln of e always equals to 1, and that gets us out of a serious amount of jams and logs. So if you let me just read this question we're going to do, and we're going to post it up down below so you can have a look at it yourself. It's a 25 mark question. It's similar to the ideas we feel will come up in a longer question in Project Maths in 2020. It says, scientific research has shown that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. Okay, so you've been studying maths for 6 years, or if you count primary school as well, like you've never seen an opening like that, and that throws students. But it says the risk of an accident can be modelled by the formula, and if you let me write that up here, the formula or equals to 6 multiplied by E 12.8C. Okay, so that is the formula, and that's what we care about. The rest of the story is now irrelevant. We are going to, like we've done since 1st and 2nd year, plug in stuff using brackets, and to make it a Leaving Cert question, we're going to, in certain parts, use logs. But it is very straightforward. You do not get thrown by the question, you focus on the formula. That's the important thing. It says where or is the percentage risk of having an accident, and then it says where C equals the blood alcohol concentration in percentage by volume. So the important thing to take out of this is your background base, and then realising that if you approach it in this manner, once you get this down on your page, all the questions will be the same. Okay, we're going to get into part 1 of a 3-part question here. But what's very important to realise is the examiner wants you to pass the question. They give you a few free marks almost at the start, and as long as you're composed, they should be pretty handy to get. As we've seen in this part 1, it's worth 5 marks, quite easy to get the partial credits of 3 and discuss that in a second. Or if you actually look back to the 2013 carbon-14 dating one I was telling you about, it's actually solvable using junior cert maths, and it was 15 marks, so 2.5% of your leaving cert for simply subbing in using brackets and using your calculator. And that always happens in logs, so at least take some solace in that. It says here, the legal limit for driving in Ireland is a blood alcohol concentration of 0.05%. What is the risk of having an accident with this blood alcohol concentration? Now, I've said to you, the thing that is really, really important is our formula from before. So we've got OR, again, equals to 6.E by 12.8 times C. Now, E is just a number. A lot of people think E is a variable. It's Euler's number. It's the exact same way pi is a number. It's not something we're looking for. But as I said to you, in the future, this ln of E equaling to 1, this ln of E equaling to 1 will be massively beneficial for us. But actually not yet, because it says, what is the risk of having an accident? And they've told us the blood alcohol concentration is 0.05. So all we have to do with this is put C equal to 0.05 in this formula. So like a little bit of a higher standard junior cert question because it's a power, but the exact same activity. Rewrite this formula for the partial credits as OR equals to 6 times E by 12.8 by 0.05. You just have to be confident with your calculator, make sure you're okay with that, put it in, and straight away you get an answer of approximately 11.38%. So the risk of having an accident with that alcohol in your system is that. Okay, part 2 says, find the blood alcohol concentration that results in a 25% risk of a car accident. And again, we're actually always going to be using the same formula. So OR equals to 6 by E times 12.8 C, because they're the variables, they're the things that can change. The more alcohol, I assume the more risk. So find the blood alcohol concentration that results in the 25. All we're doing here is putting OR equal to 25 grand. So we've got now that 25 equals to 6 by E 12.8 times C, and now suddenly it's a log equation. Now the numbers vary, but the method always remains the same. The examiner loves to put a number in front here. So what we do straight away is we divide both sides by that number and get rid of it. There are other methods of doing it, but this is the one that will blanket work for them all. So if I divide 25 by 6, I should get 4.167 equals to E times 12.8C. And here's where the actual magic of logs comes in. We have what we term here, we have a problem with powers. As in, there's a power here, we're trying to get C involved there, and our solution to always when we have a problem with powers is to introduce a log, or in this case, because it's an E, a natural log. So I'm going to put a log or a natural log on both sides. And remember, the natural log of something, again, is just a number. And some of you guys who've seen the past paper questions probably know what's coming next, because it's always the same. Now that we have a log or a ln on either side, what we can do is actually bring down the power. Remember we talked about that earlier on in the video, we can bring down that power in front. Now you don't have to know why, and some books go into teaching you why. In fact, it'll probably take up all the boards in this room and you probably still wouldn't get it. It's not examinable, you just got to trust that you can do it. Because there's logs, one of the famous rules is we can bring that power in front. So my next line on this will be, again, just keep the left hand side the same, don't do anything to that, equals to 12.8 C by the ln, or the natural log of E. Now we know from earlier, and as happens in many of these questions, that this is just 1. Anything by itself is just the exact same. So for example, 5 by 1 is 5. In this case, 12.8 C by 1 is 12.8 C. So I can just forget that. You can write it out again, but you don't have to. We don't want 12.8 C, we just want C. So essentially it's a junior cert question now. That's the exact same to me as saying, I don't know, something simple, 5 equals to, 25 equals to 5x. We don't care about 5x, we care about x, so divide both sides by 5. In this case, we don't care about 12.8 C, we care just about C. So if we divide both sides by 12.8, 4.167 over 12.8 equals to C. You put that into your calculator. Remember, be comfortable with your fractions. There's just a natural log button there for you, and you should get that C approximately to 2 decimal places is 0.11%. And that's fantastic. That, for this question, is worth 10 marks. And we feel that it could be worth even more, but we'll discuss it this year for 2020, but we'll discuss it a little bit more at the end of the video. Okay, so on to part 3. We've got 15 of the 25 marks available, and nothing that we didn't expect. And with part 3 as well, it's actually going to be the exact same. It's going to step it up a little bit. It's what we call at the Dublin Academy a grade separator. We want to be coming out of it with something, but hopefully at the end of this video you'll understand how it's all actually the same. We're just going to get one answer and sub it back into something else. Very similar to trigonometry, where we get something in a triangle and it helps us in another triangle. It's like a link. But let me read it here, because it's very often the wording that confuses students, but we said do not let that happen. The blood alcohol concentration of a male drinker is given by the formula C equals to 1.668 U over M minus 0.015 T. So that's a mouthful. It's obviously a brainful in the heat of an exam. You're stressed. You're like, what the hell is this about? I've never seen something like this. I have it on the board there for you. Okay, where do these formulas come from? We don't care. They come from the exam. We don't know how they're developed, and we don't care. Okay, just that they're there. It says U is the number of standard drink units consumed, grand. M is the body mass of the drinker in kg, grand. And T is the time over which the drinks are consumed in hours, grand. And I assume that in the next part of this question they're going to give us little digits for these that we can just fill into that formula, because that's what happens all the time. It says a man with a body mass of 82 kg, so 82 kilos, has 3 beers, the equivalent of 5.8 standard drink units over a period of 90 minutes. So what are our figures? We've got 82, we've got 5.8 standard drink units, and over a period of 90 minutes. Be careful with this. Again, particularly the stronger students may mess up here, because they feel, oh, I know what's going on here, I'm comfortable, and then they make a small mistake. And that very often happens. It's not the really tricky questions that get students, it's the ones that they're confident in. They're already thinking about the next one. 90 minutes, but they said T is the time in hours. So we've got to make sure we convert that 90 minutes to 1.5 hours. And then it says, anyway, if the man decides to drive home, estimate the risk of him having an accident. Okay, so what is this? What's going on here? Well, the new formula that we have, that they've given us, is going to give us C, grant? And our original formula over here has C in it. And what do they want? They want us to estimate the risk. We want to find R. So our general plan here is, let's throw these things into this. We're going to get a number for C. We're going to put it in here, and we're actually going to use our idea from part 1, which is junior cert stuff. We're going to put our stuff into our calculator and get a number for R. So when I did it, and I put these things into C, I had C was equal to 1.668, U was 5.8 over the body mass of 82 minus 0.015 T. So remember, be careful with this, the T is 1.5. A lot of people may put in 90 and lose out some silly marks. And I ended up getting 0.095%. Grand, remember that was C. So we're going to sub it back in up here. So our risk, the thing we are looking for, is R equals to 6 times E, 12.8 times 0.095. And just on a side note, I know there's decimals involved and this looks very, very messy, but we don't really mind, because it's the calculator that's going to do all the heavy lifting for us on that aspect. They have to put in decimals to make it seem like a higher standard, but we can see that it isn't. In fact, we're going to put this into our calculator, get an answer for R, and R was 20.24%. That's the risk of accident. And you will see that then that we've completed a 25 mark question, quite similar to the one we expect to come up in this year's paper, only using one rule of logs, one law that appears all the time. Now we expect it to be expanded a little bit more in the paper with equations and maybe popping up in different areas. We'll deal with that more in the future, but hopefully I've convinced you with a small bit of intelligent background knowledge and applying it to questions that they are actually the same ideas, the same skills again and again and again. And that's what we like to do here for our exam focus.